Hi there, hope you have a fantastic day today. This lesson I will teach you how to find equations of the normal to a curve. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, so to find the equations of the normal to a curve, so let me just draw a diagram out first, okay? So we have ln of 5x. So ln of 5x is just roughly like this because we know that ln of x is like this, right? So this is 1 and then this is x-axis and y-axis. And then at x is equal to 1/5, it's just roughly here, doesn't really matter at this point. And this line here is the tangent. So this is the tangent, and the question is asking us to find the normal. Okay, so the normal is this line here. So this is normal. So we need to find this equation here. So to do this, so first step is we need to find this gradient first. So that is m1. Let's name this m1, okay? And then from there, we can find the gradient of normal, which is m2. And we know that this is normal, which is 90 degrees for that two gradient. They are perpendicular, if you like. And the rule is, we know that m1, the gradient of the tangent, times m2, that is the gradient of the normal. And it gives us -1, okay? So now what we do exactly the same as finding the equations of the tangent. And step number 1, we need to find the point. Okay, let me just write this down. Step number 1 is we need to find the point, which is P of at x is 1/5. Now to find the point, so we substitute 1/5 is into here because x is 1/5. So let me just write this down. So when x is equal to 1/5, so the y value will give me ln of 5 times 1/5. And 5 times 1/5 is 1. And we know that ln1 is 0. So therefore, the point is 1/5 and 0. So let me write this down. There you go. So we have the point. Now what we need to do is we need to find the gradient. Okay, that is step number 2. So step number 2 is we need to find the gradient. So to find the gradient, now to find the gradient, we need to find the gradient of the tangent first. We need to find the gradient of this. And then we know that m1 times m2 is equal to -1. So we use that rule to work out the gradient of the normal. So first of all, to find the gradient of the tangent, we differentiate the functions first. Okay, keep that in mind. So we know that ln 5x is the function. To differentiate this, the rule is this. So y is ln of f of x. To differentiate this, we differentiate fx. So y dash is f dash x. And then we divide it by the function that is f of x. And in this case, f of x is 5x. So we differentiate 5x, give me 5. Okay, so therefore, y dash is equal to 5 divided by f of x. And f of x is 5x. Of course, we need to simplify that. So divided by 5 on both numerator and denominator. That's give me 1 and 1. And the answer is 1/x. So let me move this up. So therefore, y dash is equal to 1/x. So that is the gradient functions. To find the gradient of the tangent at point 1/5 and 0. So we just substitute the point in. So at 1/5 and 0. So that means x is equal to 1/5. So we substitute 1/5 in here to give us the gradient at point 1/5 and 0. Okay. So y dash will give me 1/1/5. So 1 divided by 1/5. So that is exactly the same as 1 times. We flip the fractions, become times 5 over 1. So the answer is 5. So therefore, the gradient of the tangent, that is m1, is 5. But we need to find the gradient of the normal. So we need to find this gradient here, okay? So we know that m1 times m2 is -1. So y1 perpendicular to y2. So this means that m1 times m2 is -1. And we know that m1 is 5. So therefore, we just substitute m1 in. So 5 times m2 is equal to -1. Or you can just write 5 times m is -1. The reason we use m1, m2 is just to identify their different gradient, okay? Just remember that. So if we divide by 5, so m2 -1/5. So therefore, the gradient of the normal is -1/5. So now, let me just rewrite all of those. So we know that the m, that is the gradient, is -1/5. And we know the point is 1/5 and 0. So now we can just find the equations of the normal. So we know that the rule is, step number 3, we can just use y minus y1 is equal to the gradient times x minus x1. And we know that the gradient m is -1/5 and x1 is 1/5 and y1 is equal to 0. So now we just substitute that into the formula. So y minus y1 is 0 equal m. M is -1/5, so -1/5. And x minus x1. And x1 is 1/5, so -1/5. So there you go. So what I do, I just simplified it further. So to simplify, we know that -0 is just 0, right? So on the right hand side will give me y is equal -1/5 x minus 1/5. So what I do now is I times everything by 5, okay, just to make it simpler. So we can either give the answer in y is mx plus c, or we can make it into general form. And in this case, general form is look more simpler because we don't want fractions, okay? But if you write y equal mx plus c, still correct, okay? Nothing wrong with that, but simpler if we write in general form. So the general form is ax plus by plus c is equal to 0. And the general form is for a, b, c, it must be whole number and a must be greater than 0, okay? Keep that in mind for me. So what I do now, I times both sides by 5. I times this by 5. And this cancel out. And now on the left hand side, so 5y is equal to, so we left with -1. Okay, so -1 brackets, so x minus 1/5. And now I expand the brackets further. So that becomes 5y equal negative times x, that is -1 times x is -x. And negative times -1/5. So that become positive. So plus 1/5. Again, I need to get rid of the fractions. So what I do, the whole equation here, I times the whole lot by 5. And then this time by 5. So there you go. So now we just write it out. So 5 times 5 is 25. So the answer is 25y. So that is 25y. And then negative x times 5 will give me -5x. Okay, so minus 5x. And 5 times 1/5 is 1. So the answer is plus 1. So there you go. But then I rearrange, so it becomes ax plus by plus c is equal to 0. So now to make it positive, I move this on this side. So that will give me 5x plus 25y, and the 1 I move on this side becomes -1. So -1, which is equal to 0. So there you go. This is the equations of the normal to the curve y is equal to ln plus 5. So this is the equations that we just found, okay? Please pause the video and try this one yourself. Hi there, how do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So step number 1, we need to find the point first, okay? So xy. So we know that x is equal to a half. So therefore, we can substitute x in here to find the y value and x as well. So at x is equal to a half, y is equal to ln 2 lots of a half, because x is a half. And then we add 4 times a half. So we know that ln a half, so a half, so 2 times a half is 1, so ln 1, and then we add a half of 4 is 2. So the answer is ln 1 is 0 and plus 2, so the answer is 2. So therefore the point is a half and 2. So there you go. For first step, we found the point, and second step, let me write this down so you know the process, and we need to find the gradient. Okay, to find the gradient, first of all, we need to find the gradient of the tangent first. Now to work out the gradient of the tangent, first step is we need to differentiate this first so that we can find the gradient of the tangent. Okay, so let's find the gradient of the tangent first. So y is equal to ln 2x we plus 4x, and we differentiate that, so that becomes, so we differentiate the functions, so differentiate 2x is 2, and then we over 2x, okay, don't forget. So differentiate that, give me 2, and over 2x, and then we need to differentiate 4x, so differentiate 4x is 4, so the answer is plus 4. So now let me just simplify a little bit further by dividing by both sides on this term here by 2. So the numerator cancel, give me 1, divided by 2, give me 1. So 1 over x. So let me write this down. Y dash is equal to 1 over x plus 4. But then that is the gradient of the functions. But then what we do, we need to find the gradient at point a half 2. So at point a half and 2, so the gradient of the tangent is 1 over a half, and then we add 4. And 1 divided by half is 2, 2 plus 4 is 6. So the gradient of the functions, so the gradient, okay, of the tangent is 6. So now we know that m1 is equal to 6. And we know that m1 times m2, let me just write here. m1 times m2 is -1. Now, because we know that they are perpendicular or they're normal to each other, so therefore, to find the equation of the normal, so therefore, to find the gradient of the normal, we just use this formula, okay? So m1 times m2 equal -1. And we know that the equation of tangent is 6. So 6 times m2 is equal to -1. So m2 is -1, 6. So that is the gradient of the normal. Now what we do, we just use this equation here. Y minus y1 is equal to mx minus x1. And let me just note this down. So we know that m is equal to -1, 6. And we also have the point is a half and 2. Okay, so a half and 2. So now we just substitute this. So don't forget, this is x1 is a half and y1 is 2. So now we just substitute in. So y minus y1, so that is 2, is equal to m. M is -1, 6. So write this down. X minus x1. So x1 is a half. So x1 is a half. So now what I do, I just Want to get rid of the fractions, so make it into general form. Okay, easier. So I times 6 on both sides. So get rid of the 6. So I times 6. And this one I times by 6. And the 6 cancel out. So don't forget. So now what I do now, I just expand these brackets. So let me just move this up. So this is 6y minus 12 is equal to, now negative 1 times x will give me negative x. And negative 1 times negative a half becomes positive. So plus a half. There you go. Then we want to get rid of the half. To get rid of the half, we times everything by 2. So the whole lot, we times by 2. So the whole lot here, we times 2. And the whole lot here, we times 2. Put in front, okay? So now, we just remove the brackets. So this time together, 12y. This time that, so 2 times negative 12 is negative 24. Equal 2 times negative x, it give me minus 2x or negative 2x. And then 2 times a half, it give me 1. So we add 1. So there you go. So now what I do is I write in form of ax plus by is equal to 0. And remember, a must be positive. The value of a must be positive. In another word, we have negative here. So we move on this side. So will give us positive 2x. So 2x, we add 12y. And this positive 1 here, we move on this side, becomes negative 1. So that becomes minus 24 minus 1. So that means negative 25. So minus 25. That is equal to 0. So that is the equations of the normal to the curve. Okay, so I hope you got it correct. And thank you so much for watching. Bye.